Okay, in Screencast 5.0 we talked about the real key material regarding electrons, the fact that it's all about the valence electrons. To a first approximation, you take a look at that, you ignore other stuff, and you can predict chemical reactivity the vast majority of the time. We'll spend the remainder of this unit talking about the inner details of where the electrons are, really nailing down exactly where they're located in an atom, the shapes of each part of those electron groups that will become known as orbitals, and even right down to the directions that those electrons are spinning in. So it'll become atomic orbital theory, and let's look at some electronic patterns. This is Screencast 5.1. We're going to look at this thing called an Aufbau pattern. Aufbau is German for build up, and it's a good place to start. It's a little bizarre, but I hope you find it interesting. This is Screencast 5.1. Okay, the key to understanding everything is really about the electrons, and we already mentioned the importance of the valence electrons. I hope I rammed that in, but now we're going to take a look at something a little different. Bear with me while we start looking at a strange but symmetrical pattern. We've got a nice little checkerboard here, and please fill in the following numbers. I'll explain why in a minute, but look for a mathematical pattern here. Put all 1 through 5 there in the whites. We're always going to be just writing in the whites, and then begin with 2 through 6 there, 3 through 6 there, 4, etc., 5, and just follow that pattern until you end up with the number 10 in the corner. Good. I know I haven't said what this is all about, but just check it out. Put either an S, a P, a D, and an F. I wish they went like just A, B, C, D, E, F, G, but they didn't. They did after F, so you do S, P, D, F, G. Were there to be more letters, you'd go H, I, J. S, P, D, F, G, S, P, D, F, like so. S, P, D, D, S, P, S, P, and S. You should have an S right there. Note that you could have just drawn the S's diagonally, P's diagonally, and like that. Sweet. Okay. Now give me a little subscript starting with 2 and working your way up by 4. So let's take this entire diagonal and make it 2. This entire diagonal, write a superscript that is 6, 10, 14, 18. Notice that it goes up by 4 each time you go. Alright, if you think you're so smart, I want you to tell me what this next row, which would have a white there and a yellow there, what the next row would look like. Because if you're following this pattern, you realize that it can continue infinitely. Yes, this will have something to do with chemistry. Okay, so the next row has got to look like this. Shift this down, draw another block if you need to, but in this white block here, it would be 6H22. Pause the video and do the rest of them. I really hope you did. I hope you have, because I'm going to show you the rest of them. Did you get 7G18, 8F14, 9010, 10P6? I hope you did. I think there's a yellow block. Is there? Let's see. White, yellow. Yellow, white. Yeah, so it would be right there. I think that would be 11S2, would it not? Don't forget that this can extend. It can get longer. There's no limit to how many columns you have. So that would be the next row there. Okay, so that's our strange but symmetrical pattern. Is it significant? We'll find out how significant it is in the next screencast. This is Screencast 5.1.